Chapter 4 test is
Next
Thursday, because today's Tuesday. Yeah. Let's start with some questions from Chapter 4. It's been a minute. We've been gone on break. At this point, you should have done kind of all the stuff from Chapter 4. Whenever you're ready, fire away with questions, and we can kind of go through stuff. If I do something you don't like or you're not sure about, or just in general have a question or you don't understand, you can stop me and ask. But let's start here with the questions. Kate.
On the review, can you do 1I?
Review 1I. Sure. Okay. So when we write arctan, what does arc mean when we write that in front of one of the trigs? What does it mean when I write arc in front of like tangent or cosine or sine or whatever? Oh, guys, come on. It's the same thing as an inverse, right? So that's going to be finding an angle for us, right? That's equivalent of going, okay, where is tan theta equal to 0? Good so far? On the unit circle, how do we find tangent of theta? Y over x. So you locate angle theta on the unit circle and the y coordinate divided by the x coordinate. Everybody's okay there? So where am I going to be searching for the y and x that divide to give us 0? Am I given an interval to solve this over? No. So I'm going to be using the range for tangent inverse, which I know is negative pi over 2 to positive pi over 2. So I'm going to be looking in quadrants 1 and 4 for a place where the y coordinate needs to be 0, but the x could be anything. So if I go look at my unit circle, actually I don't need to do that. I'll just scroll down to the bottom of the review. And look here at 0, the y is 0 and the x is 1. And that's the only place in quadrants 1 and 4 where the y coordinate is 0, right? So that's my answer. Is that okay, Kate? Who's next? Wade.
Can you do 5 on worksheet 2?
Worksheet 2, number 5. Sure thing. Okay. So first thing I like to do is to figure out what quadrants are covered by the interval from negative 11 pi to 12 pi. Since these are positive angles, 11 and 12, I'm going to be going counterclockwise, and each quadrant is a half. So we have 0, 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, 10 halves, 11 halves, 12 halves, 13 halves, 14 halves, 15 halves, 16 halves, 17 halves, 18 halves, 19 halves, 20 halves, 21 halves, 22 halves. That's the start. Look, 11 pi. I know, I'm excited too. 23 halves, and then 24 halves. That's the end, 12 pi. So we're looking at quadrants 3 and 4. Everybody okay there? Next, I'm going to be looking at this piece, because I know that's equivalent to saying cosine theta equals 0.19. Well, basically, I'm just noticing that cosine is positive. So if I use, yes, Maya? Sure. If I use all silly turtles crawl, I recognize that cosine should be positive in, oh my goodness, can I spell, guys? All silly turtles crawl. All silly crawl turtle? That doesn't make any sense. If I look at that, I notice that cosine is positive in A for all of them, and C for cosine. So that's going to be quadrants 1 and 4. So my answer that I'm going to be looking for should be in quadrant 4. Wait.
Did you have to like color code it?
No. You just got to get in the right spot. I'm color coding it now, so when you go back and you look, it's a little bit clearer what I did to figure that out.
Okay.
But you don't need to color code it for your own work.
Can you explain the blue shading one more
Yeah, cosine is positive.
time?
So if I use all silly turtles crawl, A stands for all sine, cosine, and tangent are positive in quadrant 1.
And then it's cosine. Oh.
And C stands for cosine is positive, but sine and tangent are negative. Is that good?
Yes.
Okay. So I'll draw my theta now. So how many times did I go around? I went 1, 2, 3, 4, 5 times around. Yikes. 1, 2, 3, 4, 5. So that's my theta. Gross. There's a lot of trips. Mr. Kulik, did you have to make this one so stinking big? No, I didn't, but that's what I did. Sorry, guys. And then I'll label my alpha. But we're almost there. So now I want to write an equation that relates theta, alpha, and 12 pi together. Why 12 pi? Because it's the other arm of my angle alpha, right? Alpha is always the acute angle between the x-axis and the terminal side of theta. So if I look at this picture, is theta less than or greater than 12 pi? Does it stop before I get to 12 pi or after I've crossed 12 pi? it stops before, right? You know, going around, there's 2 pi, there's 4 pi, 6 pi, 8 pi, 10 pi, and then haven't gotten around all the way again to get to 12 pi yet, right? So it happened, so it's something less than 12 pi, right? Is everybody okay with how I looked at my picture and came up with that? How much less than 12 pi is it? Alpha less, right? If I go alpha more, I'll be right at 12 pi then. So that's the equation I'm going to use to solve for theta. All I need to do is get alpha, which in this case is going to be cosine inverse, and then absolute value, 0.19. Always absolute value on your alpha. And now it's calculator time. When I type this into my calculator, what do I have to be careful about? My mode, particularly in this chapter, because we've been using our calculator sometimes in degree and sometimes in radian. I know my answer should be in radian because the interval I was given was in radians. So I'm just going to double check. Oh, it's a good thing I double checked. I was in degree mode. So now I'm going to do 12 pi minus cosine inverse 0.19. Mr. Kulik, you didn't type in the absolute value symbols. I know, but I did in my head. Right? The absolute value of 0.19 is just 0.19 because it's already positive. It's okay. I'll press enter. So there's my answer, 36.32. How do I check this? Well, cosine of my answer ought to give me 0.19, right? Yes! Ready to see the check? That's only part one of our check, though. What else do we need to check? Yeah, that it fits in between 11 pi and 12 pi. So all I'm going to do in my calculator is type in 11 pi. That's less than 36. And I'll type in 12 pi, which is bigger than 36. So what are we convinced? You ought to be, right? Meets both criteria. Cosine of that theta gives us 0.19, and that theta is in between 11 pi and 12 pi. So we're good. Wade, did that feel okay?
Yeah, a little bit. Can you maybe do that?
Sure. 6? Sure. No problem. So we'll start the same way. We're going to look at the interval, and we're going to look at what quadrants are covered from 4 pi to 5 pi. So again, positive angles. I'm counting counterclockwise by halves. So 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, that's the start, 9 halves, 10 halves, that's the end. So we're covering quadrants 1 and 2. Everybody's okay there? Wait on your test or whatever if you want to do something like that and just circle the 2 quadrants.
Okay.
If you don't have a marker or whatever, that's fine. I see a lot of you guys doing that. That's what I would do if I didn't have a highlighter access where I have infinite pen colors working on one note. Then I'm going to take this. I know that this is equivalent to just saying tan theta equals negative 0.95. So that's negative. If I do all silly turtles crawl, I see that tangent is positive in quadrant 1 where it's A for all, and quadrant 3 for T, which means it's negative in quadrants 2 and 4.
How do we know where it's positive?
So all silly turtles crawl. A stands for all. Sine, cosine, and tangent are positive. S stands for sine is positive only, so tan and cosine are negative. So that was one of them that I was looking for.
And then tan and cosine are always negative?
So the letter tells you what's positive. So S stands for sine. Sine's positive. If the thing's not positive, what is it? Negative. So in quadrant 2, S means sine is positive, so cosine and tangent are negative. In quadrant 3, where it says T, that means tangent is positive, so sine and cosine are negative. In quadrant 4 with the C, that tells us cosine is positive, so sine and tangent are negative. Is that okay? So notice in quadrant 4, we also said tangent was negative, right? Oops. All right. So if I look at this now, where is my answer at? It's got to be in quadrant 2, because that's the place where we have the overlap. So I'll draw my terminal side. So far, so good. And now let's draw our theta. So we'll go to 2 pi, go to 4 pi, and then we'll stop at our terminal side. So there's my alpha. And I want to relate theta, alpha, and the side of the x-axis that forms the other arm of alpha. So 5 pi. So if I look at theta and 5 pi, is theta smaller than 5 pi or bigger than 5 pi? Smaller, because it stops before we get to 5 pi, right? So we know that we're going to be subtracting because it's less than 5 pi. How much do we need to subtract? Alpha. And in this case, alpha would be tan inverse absolute value negative 5.95. Now notice when I type this into the calculator, I'm not going to bother with the absolute value. I'm just going to make negative 5.95 positive in my head because I can do that in my head. Mr. Kulik, I don't need a calculator to do the absolute value of a number. I got that. So the answer there should be 14.30. If I wanted to check that, I could do tangent of that number, and I should be getting what back? Negative 5.95. Yes. And that number, 14.30, should be smaller than 4 pi and bigger than 5 pi, right? So 4 pi is Smaller. Great. 5 pi is bigger. Yes. At that point, I'm convinced. Yes, wait.
Do that thing where you got tan as the answer.
So what I did is I did tan and I pressed second and the negative sign, and that'll give me the ants.
Okay.
But I can't do it now because the ants that I wanted was this number up here, the 14.3.
So you have to do it like right
So you have to do it right after you type that in. Because ants is just whatever the previous output from the calculator was.
Okay.
You can also do, if you do this, you can do like tan of, and then you can just like scroll up
Okay.
and press enter and put it in. But there you're not getting all the decimal points. So when you do that, you won't get exactly, but it'll be close enough for you to go, good enough.
Yeah.
So you do it that way too. Happy? Okay. Miriam.
For like this test, like, are we ever gonna need our
Yeah, for sure. The story problems were all degree problems, right?
So that's it?
I think so. Unless the directions ask, the directions always tell you the mode of your calculator.
Okay.
You just have to read the prompt directions for the problem, which I know is a challenge for some of us. We get going and we're like, yeah, okay, I see the type of problem this is. We don't read the direction, and sometimes that gets us. Wait,
Can we do a story problem or two, like chapter 4, worksheet 3?
yeah, yeah. You got one in particular you're interested in?
I mean, just one for now and then.
Okay.
Is that okay?
Yeah, of course. I don't know. Let's do 4 or something. The Steel Dragon 2000, a roller coaster in Japan, has a hill on which the car will travel 350 feet on an inclined track while rising 318 or to a 318 foot height. What is the approximate elevation, angle of elevation for the hill in degrees? So we have some start here. We're going to go up some incline, 350 feet. And the height of that incline is 318 feet. I can assume that we're just talking about straight up and downsies. So that's a right angle there. And the angle of elevation for the hill is going to be that angle from the start line to the incline, right? So relative to this angle theta, the two sides we know are opposite, adjacent, or hypotenuse. Hi, I have class. What are those two sides? Let's start with the 318. What's that? Opposite, adjacent, or hypotenuse? Opposite. Good. And the 350 is? Okay. So which trig function should I be using for opposite and hypotenuse? Sine. Because I know SOHCAHTOA, right? Yes. Nope. Because it says angle of elevation.
Oh.
Declination. It would be like that angle. Nope. Oh, yeah, sure. Yeah, it'll be the same number for this picture, for sure.
Are there any that we need to know, like the CSC thing?
The CSC thing, yes.
So can we make like an edit chart note card and throw those in or no?
Just talk to me after class. I'll be happy to let you do that if you'd like. Okay, so far we're not done with this one yet, though. I just wanted to. We've had a lot of sub questions inside of this question, which is fine. Go ahead and do that. I just want to make sure that we're everybody's on board that we haven't finished this yet. Wade, you good?
Yeah.
Okay. I saw your hand. I wanted to just before you said anything, I was like, we're not done yet with this one.
Yeah.
So to get the theta then by itself, I'll do the sine inverse of both sides. And then it's calculator time. What mode should my calculator be in?
Degrees.
How did you know that? The problem tells you degrees, the directions. Read the directions if you're not sure what mode your calculator should be in. Even if you think you're sure, still make sure you read the directions. There's oftentimes good stuff in there. So I typed it in, but before I press enter, I'm going to change the mode to degree. So about 65.3. Yes, Dom. Sure, say hi to Charlie. Yes, Wade.
You don't have to you don't have to put the whole number in there.
Yeah, 1 or 2 decimal places is fine.
Okay.
Yep. Because it says, again, directions have approximate, so rounded is fine.
Oh.
You know. And typically three, 1 or 2 decimal points is plenty. What's up, Miriam?
That's the answer.
That's the answer. That's it.
Because I remember there was one with a lot of stuff.
Yeah, there's one with a lot of stuff.
Is there going to be one like that on the test?
I don't really remember because I wrote the test literally 2 weeks ago. I can't remember. Yeah, sure.
That thing of declination too. What is that? Did I say it right?
Yeah, I think we use depression, but declination is fine. I said that, so.
Okay.
Well, let's do 5 then. Right? Standing on top of your friend's 20-foot tall house. You notice a dog chasing a squirrel. Yes. You have a 40 degrees to the dog. And then, and then 50 degrees to the squirrel. So the squirrel's probably it is that. I did have that right. It's a dog, squirrel. Okay. So this. Oh, no, I did have it. I'm so. Gosh darn it. Okay, that way. So angle of depression is 40 degrees to the dog and 50 degrees to the squirrel. Yeah? Or we can do this. The place where you don't want to put it is in that corner. Nothing ever goes in that corner. It's always relative to a horizontal. Everybody's okay? Okay. Then it asks how far apart are the the house is 20 feet, right? I forgot to write that. It says how far apart are the 2 animals? So we're looking for that distance right there from S to D. So far, so good? I can do this without a ton of steps, but I'm going to do a little. I'm going to just call those corners B and T for bottom and top. So if I look at this, I see 2 right triangles. I see this one. And I see that one, right? And I notice here that x should be then just a difference between BD and BS. So far, so good? Bottom, like the bottom of the house, T for the top of the house. I don't know, I needed a letter so that I could label the triangles in a way that allowed me to talk about them. So far, so good? Okay. Well, if I look at the first triangle, relative to the 50 degrees, the side I know is opposite, adjacent, or hypotenuse. Opposite. And the side I want to know about is opposite, adjacent, or hypotenuse. Adjacent. So which trig function should I be using? Tangent. So I'll say that tan of 50 is equal to opposite over adjacent. And now I'll solve for BS. So I'll cross multiply, because that's a solving technique, not a multiplication technique. And then divide by tan 50. Okay. So if I go to my calculator, I can just type that in now. 20 divided by tan 50. But what do I have to make sure? I'm in degree mode. Well, I know I am. I just changed it there for the last problem, but just wanted to reiterate. So that's about 16.78. Now, if I look at the next triangle, relative to the 40 degrees, 20 is opposite, adjacent, or hypotenuse. Opposite. And the side we want to know about, BD, is that opposite, adjacent, or hypotenuse. So which trig function should I use? Tangent. So I'll say tan 40 is equal to opposite over adjacent. I'll do the same, cross multiply, and divide by tan 50. And now it's calculator time. Oh, I meant tan 40. I wrote 50 at some point. I got 50s in here. Gosh, dagnabbit. Makes me feel silly. You should feel sillier for not catching it, though. You're just blindly copying whatever I wrote down, didn't you? I caught you. All of you! So I have 2384. So far, so good. And what was x again? The piece that we actually wanted was just BD minus BS. So 705. No system needed on that one. But it had angled depression, which was what Miriam wanted. And it was more complicated than the previous one. It wasn't the worst version of this kind of a problem, though. Kate. Of course. Miriam.
Okay, so We did the two triangles because it asked for 40 degrees and 50 degrees.
Yeah, wanted how far apart were S and D.
Yeah, okay. And then, so like usually, like it, like when it usually asks for like two, angle measures or just like put it up one. And then how like 40 and 50, or like really called the test or something. Like you do like multiple like that where you have to do like two triangles.
Oh goodness, are you asking what's on the test again? Didn't I just say that I wrote it like 3 weeks ago and I don't really remember what I put on there? Whether I had like what level of difficulty a problem this is?
Do you think you would make it difficult, or do you think
I don't think I would make it any worse than this one.
Okay.
But again, it was 3 weeks ago. I promise you I don't really remember. You know? I'm trying. I just don't like you write 3 versions because we have 3 classes, and then like,
We have to make different versions.
do I have to?
Well,
No.
you don't have to.
But like, do I?
That's
Yeah.
so much work. Yeah, just make one. Give yourself a break.
Yes, Wade.
Maybe I'm like, I don't know, but I got 7.06.
You got 7 what?
0.06, and you put 7.
It would depend on like what you type. I mean, did you use these rounded numbers
Okay.
versus the whole decimal? And again, like on a test, like I wouldn't quibble with 100th,
Okay.
right? Like if your 100th was one different than mine, and you wrote down like the rounded one minus the rounded one, and it was clear what you did to get the 100th. I don't care.
Okay.
Like I'm not gonna be that, I'm not like a maniac about it.
Okay.
You know what I mean?
Yeah.
It's just like when I do it, I'm gonna keep as many decimals as I easily can. You know, that's just like how I do it. But like, use the rounding. Like I don't. It's fine if it's clear what you did. Like I'm not gonna lose my noodle about that kind of thing. I wouldn't mark you down for. Oh, use the intermediate rounded answers to get your final answer, and you're off by 100th or something. Like whatever. No big deal. Is that? You're good?
Yeah.
Okay. Yeah, and that can happen. It's not a big deal. Now, if you're like working at NASA designing a rocket to try to land on the moon, those hundreds matter because they add up and then you miss the moon, and that's embarrassing.
We're not trying to get.
No, we're not trying. Nobody's trying to get to the moon in this class. We're just trying to get to the end of the semester, I think, with everybody intact, right? Maybe Jake's trying to get to the moon. Because he's sleeping. Maybe he's dreaming about it. Moon people, moon people.
He's dreaming about this.
These math problems. Oh, he heard us. How are you guys? We feel okay on this? Ish? Any better? Little better? I'll go for this much better. If it's this much better, I'm happy. Yeah? Miriam. That's okay.
So for the angles of depression, or like when I saw like depression, the triangles always will have how you have them, and then for elevation, it really doesn't matter what way. You know what?
Does it matter? Yes.
Okay.
So again, an angle of elevation is going to be from all angles of depression or angles of elevation are going to be from a horizontal to the line of sight, right? Now, a depression is from the upper horizontal down, right? Like,
it's like a dumb question. Like,
yeah, like the arrow's kind of going down for a depression. And for elevation, they're going like up.
Once I asked up,
But like,
never mind.
is for a situation, the angle of depression is going to be the same measure as the angle of elevation. So in that regard, whether you write it as draw your triangle with an angle of depression, or you draw your triangle with an angle of elevation, that doesn't matter. But your picture needs to be correct. Like, does it matter where you put it? Well, yeah, it's got to be in one of those two places. You can't just like put it wherever. Like if you put it here,
Outside.
that's going to be wrong, right? But it has to be between a horizontal and that line of sight. I think I answered what you're trying to ask? I just want to make sure because I didn't want to I think you knew what I was going to answer and I knew what you're talking about, but there was a lot of possibility for misunderstanding what I was answering there. I didn't want that to happen. You know what I'm saying? Yeah, probably need to start chapter 5 here. Okay? Do a little bit of that today. 2. But though I felt like that was productive. Do you guys feel like you got something out of asking some questions, made a little bit of progress, at least refreshed your memory of oh yeah, I knew how to do that one point. I don't feel very good about it right now. I better look over that. At least that, right? We got to there. So our plan here in chapter 5 is we're going to learn how to solve more complicated trig equations. So in the previous chapter, we learned how to solve just the most basic of basic trig equations, like sine theta equals 0.57 or something, right? That sounds like a chapter 4 problem. Here in chapter 5, we're going to learn how to solve equations like sine squared times cosine, or sine squared theta times cosine theta minus cosine theta equals 0. Ooh, scary. In order to do that, we're going to have to build ourselves some additional tools. And that's what we're going to be doing in today's lesson, is kind of building those tools and practicing using them after. Okay? So this section is titled Fundamental Identities. When we talk about an identity in math class, what we're talking about is like an equality statement that's true for all values of a given variable. So some examples of identities. And you could have something simple like x equals x. Right? That's an equality statement, has an equal sign in it. Always true for all values of x. 2 is equal to 2, 7 is equal to 7, negative 4.6 is equal to negative 4.6. Everybody happy with that? You could have something like this. That's another example of an identity. How do I know that those two things are actually equal? What happens if I distribute out the right-hand side? I get the same thing as left-hand side, correct? Or what happens if I took a greatest common factor of 2 from the left-hand side? I get the right-hand side, right? Everybody's okay with that? Or you could have something like this. That's another identity. How do I know the two sides are equal? If I FOILed the right-hand side, I should get the left-hand side, which I will. Or if I factored the left-hand side, I would get the same thing as the right-hand side. Everybody's okay with that? At this point, we already know a whole bunch of trig identities. You just didn't know it. Can somebody give me one? Let me give you a hint. What's the relationship between sine and cosecant? They're reciprocals. So I could write like cosecant theta equals 1 over sine theta. Right? And I should be able to do that for all 6 of the trig functions. I could write something like this, correct? Well, guess what? Those are going to be our first 6 identities. We call these the reciprocal identities because, well, hey, they're just like reciprocals, dude. Is that okay? So just writing down things that we already knew, but we hadn't formalized it so neatly. So let's keep going. Let's look for some more of these kind of relationships. There's another one that we already kind of know. So on the unit circle, if I ask you to find tan theta, how do you do that? How do you find the value of tangent on a unit circle? It's way too much hesitation. It's a chapter 2 question, my dudes. So you find your angle theta on the unit circle, right? And then you do y over x. Very good. Right? And on the unit circle, what is y the same as? It's a lot of hesitation for something we should be able to spit right out. Sine theta is correct. Good job. And x then is cosine theta. So that's an identity. Tan theta is equal to sine theta over cosine theta, right? And since cotangent is the reciprocal of tangent, what is cotangent equal to? Excellent. Cosine theta over sine theta. Those two together are what we call the quotient identities. We already knew them. We just didn't know that we knew them. Hey, that's pretty cool, Mr. Kulik. I love when I know stuff that I didn't even know that I knew. It's a funny sentence to say. So let's say now, to figure out our next kind of identity, let's say we're living in some right triangle. And I'm just going to name the sides of this right triangle opposite, adjacent, and hypotenuse. And I'm curious to see what sine theta plus cosine theta, or sine squared theta plus cosine squared theta is equal to. How do I find sine of an angle inside of a right triangle? We use SOHCAHTOA. So sine is opposite over hypotenuse. These answers should come so much faster, guys. Come on. It's okay. Cosine is, there you go. That's better. So sine squared theta should be opposite over hypotenuse squared. And cosine squared theta should be adjacent over hypotenuse squared. So far, so good. How do you square a fraction? It's a 6th grade question. What do you mean by both of them?
Square
Excellent. That's correct. Yeah. You square the top and you square the bottom. So this just becomes opposite squared over hypotenuse squared plus adjacent squared over hypotenuse squared. So far, so good? What do you notice about the denominators of those two fractions? So what can I do with them? I can add those two fractions together because I have a common denominator. All right, here's the hard question. Opposite squared plus adjacent squared, what does that equal? Hypotenuse squared. Why? The Pythagorean theorem, a squared plus b squared equals c squared. Great. That happened much faster than the previous classes. Maybe me getting on your case a little bit works. Okay? Everybody's good with that? What's hypotenuse squared divided by hypotenuse squared? No.
Oh, wow.
1, right? So hold on, wait a minute. What have we gotten here? Sine squared plus cosine squared is 1. That's what we just showed. Oh, that's an identity. We can do that 3 different ways, and those 3 different ones are what we call the Pythagorean identities, because what do we need to use to do them, or to get them? The Pythagorean theorem. So those are the 3 Pythagorean identities. Just to be clear, what I'm doing right now is we're just discovering things together. I'm not doing any problems. I haven't shown how we're using these things. I'm just kind of showing you that these identities, Mr. Kulik isn't making up out of whole cloth, that we could discover these on our own by looking at things that we kind of already know. You know what I'm saying? So is this a process I'd expect you to be able to repeat? No, man. This is just like, so you don't think that Mr. Kulik's a liar, liar, pants on fire, and these things hopefully make sense to you. So the next set, if we look at the unit circle, have you ever noticed that like sine of 30 degrees is 1/2, but that's also the same thing as cosine of 60 degrees? Or maybe that sine of 45 degrees is equal to root 2 over 2, and cosine of 45 degrees is also that? Or that sine of 90 degrees is equal to 1, and so is cosine of 0 degrees? If I look at these pairs of angles, what do you notice about them? They all add up to be 90 degrees, right? What was the name for angle pairs that did that in geometry? Close. You have the right 2 first letters. Complementary is the term that you're looking for. So, can I tell you a secret? You know the co in front of cosine, and in front of cotangent, and in front of cosecant? That co is an abbreviation for the word complementary. So like sine and cosine share this complementary relationship. Secant and cosecant share this complementary relationship. Tangent and cotangent share this complementary relationship. Essentially what we're seeing here is that sine 30 is equal to cosine of 90 minus 30. right? That's an identity. Because it's not true just for like 30, 45, and 6, or 30, 45, 60, 90. It's true for any angle. So we're going to call these guys the cofunction identities. Notice here that instead of using 90 degrees in our identity, we're just using pi over 2, which is the radian equivalent of 90 degrees. That's okay with everybody? I think we've hammered that fact home pretty good with our counting of quadrants in the last chapter, that 90 and pi over 2 are the same thing. 90 degrees and pi over 2. Yeah, right? So that's just the radian version of that. And our last piece, remember odd and even functions way back from chapter 1? What was the definition of odd or even? I'll give you a hint and let's start it out. So it starts f of negative x equals, and what's the rest of it for an odd function? Or even, if you prefer. Who remembers the definition? Oh, you guys, mathematics is all about your definitions. Odd functions, it's negative f of x. Even functions, it's regular f of x. Now, do you remember also in chapter 3 when we graphed sine, cosine, and tangent, we noticed that cosine was even and sine and tangent were odd. And if a function is even, its reciprocal should be even, so secant is even. And if it's odd, its reciprocal should be odd, so cosecant and cotangent should be odds. So as a result, if I have sine of negative theta, that should equal negative sine theta. Or if I have cosine of negative theta, that should just be cosine of theta. Those are identities. We can write 6 of those, one for each of our trig functions. That is all the identities we're going to be looking at in this course. As a kind and benevolent teacher, I've gone ahead and consolidated all of those identities onto one sheet. You'll notice here, all of them all in one place. Oh, how nice. Thanks, Mr. Kulik. You're welcome. Now you don't have to hunt through your notes for them. Let's do one example here of using these now to do a problem, and we'll be done for today. Sound good? Too bad, that's what we're doing. All right. So here we have find sine theta if tan theta is 3 and cosine theta is negative. Well, right away, if I know cosine is negative, its reciprocal also has to be negative, right? If I take negative 4, the reciprocal of that is negative 1/4, right? Bless you. So I know that secant has to be negative also. Everybody good with that? Now what I'm going to do is I'm going to look for an identity involving just tangent and either cosine or secant on my identity sheet. So nothing here. Those all have 3 in them. Aha! Look at P3. Tan squared theta plus 1 equals secant squared theta. That's what I want. In the problem, they tell me that tangent is 3. 3 squared is 9 plus 1 is 10. I square root both sides to get the secant by itself. And then I know that secant is negative, so I can drop the plus from the plus or minus and just write that as negative root 10. And then equivalently, I know that secant and cotangent or cosine are reciprocals. So I know cosine should be negative 1 over root 10. Now, I'm going to go back to the original problem, and this time I'm going to look for a identity that relates sine, tangent, and either cosine or secant. So I'll go back to my identities. Nothing up here. Those all just have 2. Aha! If I look at Q1, tangent equals sine over cosine. That will work. Let's use that one. I know tangent is 3. How do I know that? It was given to you in the problem, Mr. Kulik. Cosine we know is negative 1 over root 10. Now I'm just going to solve for sine. So what? Cross multiply maybe? Sine theta is 3 times negative 1 over root 10. How do I multiply those two things together? It's a 6th grade problem, guys. Think about 3 as a fraction. We multiply tops to tops and bottoms to bottoms, right? But we don't like that as a final answer because there's a radical in the denominator. So multiply both the top and bottom by root 10. And we'll go with that as our final answer. At this point, hold on. You guys should be able to do 1 through 6 from the problems. When would this be due?
Sunday.
Nope.
Next Sunday.
Sunday, because we won't have a chance to talk about it before this Sunday. Remember, test on Tuesday or Thursday.
This is worksheet 1. The homework.
Problem set.
I'm going to meet with you Wednesday, Thursday, Toronto, and CT. And Thursday, I know you have cuddle in there, so just,
Yes, absolutely.
Is that so okay?
Yes, for sure. We'll see you then, Jacob. Or I'm sorry, Boyd.